So we move on to question number 7. Now in this question what is happening is there is a circle and there are two chords AB and CD intersecting each other at a point P. Now remember that P is not the center, okay? Don't assume it is the center unless it is given its center, or normally the symbol used for center is O. So here there are two chords. What we have to prove is that these two triangles are similar. So to prove them similar, this is easy. These two are vertically opposite angles. And in class 9 you have done this theorem that angles in the same segment are equal. So if you look at this arc CB, angle CAB is equal to angle CDB, angles made by the same arc. So this is CB, starting from C, going up to B, then starting from C and going up to B. So CAB equal to CDB, angles in the same segment. If I look from this side, I can say that angle ACD equal to angle ABD. Anyway, you got two angles, that's enough. So once you prove two angles are equal, then we can say the triangles are similar by AA. And if the triangles are similar, their sides are in proportion. And if the sides are in proportion, we can cross multiply. Okay, here we find the sides are in proportion, right? So once the sides are in proportion, what happens is that the PA by PD equal to PC by PB, okay, and then we cross multiply, we get the required result. Then question number 8 also can be done in the same manner. Okay, here the two chords are now intersecting each other outside the circle. In the first case it was meeting inside, now it is meeting outside. So now this is a cyclic quadrilateral. Now we know that in a cyclic quadrilateral the opposite angles add up to 180. So 2 plus 3 is 180. Angle 1 plus 2 is also 180, linear pair. So we get angle 1 plus 2 and 2 plus 3 both are equal to 180. So we can equate 1 plus 2 equal to 2 plus 3. So 2 gets cancelled, we get angle 1 is equal to angle 3. So this is an important result, that in a cyclic quadrilateral the exterior angle will always be equal to the interior opposite angle. In class 9 you have done exterior angle theorem for triangles, right? So same way, in a cyclic quadrilateral the exterior angle will always be equal to the interior opposite angle. Same way I could have said this angle here, exterior angle, is equal to the interior opposite angle here. Okay, so how to prove that this triangle PAC and this triangle PDB are similar? I have proved that 1 is equal to 3. Okay, exterior angle is equal to interior opposite angle. This is the proof. And I can say that angle P is common, whether you take this small triangle or you take this big triangle. What will happen is angle P is common, and therefore we can say the triangles are similar. If the triangles are similar, then what happens? We know that the sides are in proportion. So we get PA by PD is equal to PC upon PB, and then you cross multiply, and then we get PA into PB equal to PC into PD, the required result. Then question number 9, this is the converse of actually question number 1 which we did. So here this is the triangle, and now we have to prove that AD is the bisector. In the first question it was already given AD is the bisector. Here we have to prove that AD is the bisector, and it is already given to you that AB by AC is equal to BD by CD. This is already given. In the first question we had to prove that AB by AC is equal to BD by CD. Now is the reverse. So we have to prove that AD. So construction is same as we did earlier. So construction was that we are going to draw this line CE parallel to AD, and we are extending BA to point E. Okay, now if this is parallel to this by construction, then we can use basic proportionality theorem and say that BD upon CD is equal to AB upon AE, right? BD upon CD is equal to AB upon AE. Why? Because these two are parallel. AD is parallel to CE. Therefore, I can say BD upon CD is equal to AB upon AE by basic proportionality theorem, right? So BD upon CD is equal to AB upon AE. Now what is given to us? It is given to us that BD by CD is AB by AC. This is already given to us. BD by CD is AB by AC is already given to us. So if I compare these two equations, what happens? BD by CD is common, and therefore we can say that AB by AC equal to AB by AE. So here AB is also common. So what can we say? That AC and AE are equal. Okay, so if you compare this, all these things are equal. So from here I can say that AC and AE are equal, right? So once we prove that AC and AE are equal, then we can say that these angles opposite to them are equal. Okay, these angles are equal. Angle ACE is equal to angle AEC. Angles opposite to equal sides are equal. And then we also know that these two angles are equal because they are corresponding angles. Angle BAD is equal to angle BEC. Okay, so we get angle 1 and 2 equal and 2 and 3 equal. And what do we need to prove that? We need to prove that angle 1 is equal to 4. Now 4 and 3 are equal by corresponding angles, right? 4 and 3 are equal corresponding angles, and therefore what is the final answer? We can say 1 equal to 4. Okay, so this part is clear. BD by CD is equal to AB by AE by basic proportionality theorem, and BD by CD is AB by AC is already given. So if I compare this, I'll get AC equal to AE. If AC and AE are equal, then from here I can say that angle 3 is equal to angle 2, right? But 3 and 4 are equal. Why? Because they are alternate angles. 1 and 2 are equal because they are corresponding angles. So 1 is equal to 2, 3 is equal to 4, and therefore, and 3 and 2 are already equal. So what is the conclusion? Therefore conclusion is that 1 is equal to 4. So you can combine all this and say that 1 is equal to 4 because 3 and 2 are equal. Proved. Instead of 3 I can replace it with 4. Instead of 2 I can replace with 1, and therefore instead of 3 what will happen? Instead of 3 I'll get 4, instead of 1 I'll get 2. So final conclusion, I'll get angle 1 is equal to 4, or we can say that AD bisects angle BAC, right? So this will be the proof. So here they have not numbered. If you number, it becomes slightly easy. Okay, you can do it this way also or this way. I have just provided an alternate solution. So you've numbered the angles as shown in the diagram, right? We have to prove that angle 1 equal to 4. First I am proving that angle 3 is equal to angle 2. Okay, now 3 and 4 are equal because they are alternate angles. 2 and 1 are equal because they are corresponding angles. So what have I done? I have replaced 3 with 4 and I have replaced 2 with 1. So we get 1 is equal to 4, and hence we get the required result that AD is the bisector of angle BAC. Then the last question. Now this is the last question. Here this girl is having a fishing rod, and this is the thread, and this is at a height of 1.8, and the distance, this distance is given 2.4, and the question is after she is pulling at a speed of, a fishing rod is 1.8, and we have to, she is pulling at the rate of 5 centimeter per second. Okay, 5 centimeter per second. The question is what will be the horizontal distance of the fly after 12 seconds. Okay, so the first part is clear here. This is 1.8, this is 2.4. So by Pythagoras I can find out this hypotenuse. So 2.4 square is 5.76, 1.8 square is 3.24. So this, when you add, you will get 9, and root of 9 you will get 3. Okay, so the first part you are getting 3. Now what happens after 6? She is pulling off at the rate of 5 centimeter per second. Now you are pulling at the rate of 5 centimeter per second. Time given is 12 seconds. So what will happen? Distance is speed into time. So 5 into 12 is 60 centimeters. So what happens? Your length of the string is getting reduced by 60 centimeter. At the moment we have calculated as 3, but when it is reduced by 60 centimeter, that is 0.6 meter, now the 3 meter which was originally calculated will be reduced by 0.6. So that is why in the next figure we will have 2.4. Okay, because 0.6 has been reduced because she is pulling the string. No, when you catch the fish, the string is rolled up and the length of the string gets reduced. So after 12 seconds 60 centimeter is reduced, so you get the new hypotenuse as 2.4. The height remains same because the girl is at constant height 1.8 meter. The stick is here only this length of the string is getting reduced, so it is coming somewhere here like this. So once we get this, again apply Pythagoras theorem. 2.4 square is 1.8 square plus BC square. So BC square will be 5.76 minus 3.24. So we get 2.52. Now 2.52 is not a perfect rule. So when we calculate this, you will get approximately 1.59. Now once you do this 1.59, this length you are getting, that length has to be added to 1.2. Now this distance is given here 1.2. So what has happened, this length of the string has reduced. Okay, this length was reduced. So initially it was 3 and now this became 2.4, and this distance now we have calculated here. This distance we have got as 1.59. Now this distance is 1.59 and this girl is already at a distance of 1.2 from this rod if you take the perpendicular. So total distance from here to here, that is the length of the tip of the string to where the girl is, 1.59 plus 1.2. So we will get the total length as 2.79. So final answer we'll say the total horizontal distance of the fly from Nazima after 12 seconds will be 2.79 meters.